Hello student, in this video, we will take a look at experiment 6, conservation of momentum. When two objects collide, whether cars, shopping cart, or in this experiment, gliders 1 and 2, the result can be complicated. Yet, even in the most chaotic of collision, as long as there are no external forces acting on the colliding objects, one principle always holds and provides an excellent tool for understanding the dynamics of collision. That principle is called the conservation of momentum. The equation of momentum is given by P is equal to m multiplied with v. In this case, for conservation of momentum, the initial momentum is equal to the final momentum. P initial is equal to P final. If we take a look at the equation, P initial or initial momentum is at the left side of the equation and P final or final momentum is at the right side of the momentum. So initially we have m1v1i plus with m2v2i. These are the momentum contributed by both glider 1 and 2. It is equal to m1 plus with m2 multiplied with vf, which is the final velocity. In this case, the final velocity will be the same for both gliders because they are moving together at the same velocity and are attached to one another in order to create a perfectly inelastic collision. Firstly, set up the air track and photo gates as shown in figure 1, using wax and needle on the gliders to provide a perfectly inelastic collision. This is to make sure that glider 1 will be attached to glider 2. Carefully level the track. Secondly, measure M1 and M2, which are the masses of the two gliders to be used in the collision. Record your result in table 1. Measure and record L1 and L2, which are the length of the gliders. Set up the photo gates. Place glider 2 at rest between the photo gates. Click the start button in Data Studio to begin data recording and give glider 1 a push toward it. Record 4 time measurements in table 1. Repeat the experiment by varying the initial velocity of glider 1 and varying the mass of the other glider at 50 gram and another 50 gram on the glider.